I want to thank God Almighty for giving us the opportunity to attend today's guest lecture. Ladies and gentlemen, allow me to introduce myself. My name is Fadil Alwafaridi, and I will take part as the Master of Ceremony of this lecture and will be hosting the event until the end. Before we step in further to the material, allow me to read the series of our events for today, starting from opening from the Master of Ceremony, which is myself, praying session, documentation, and closing. Okay, before moving into the next session, let's pray for a moment. Okay, let me lead this praying session. Okay, pray, begin. Okay, pray, finish. Moving on to the next session is documentation. So please, for all of the attendants, can turn on their camera. Okay, let's begin from the first slide. 1, 2, and 3. Okay, the second slide. 1, 2, and 3. And the third slide. 1, 2, and 3. On the next slide. 1, 2, and 3. Okay, on the next slide. 1, 2, and 3. Okay, next moving on to the long-awaited session, which is a material that will be delivered by Dr. Dylan Williams. Also will be guided by a moderator, which not less extraordinary, Ma'am Erlina. To Ma'am Erlina, the time is yours. Thank you.
Okay, thank you so much, Fadil. Sorry for waiting, Dylan. So welcome to all the audience, the participants. It's already 62 participants today. Yeah? It's quite interesting. What we are going to talk about today is not about the context and problem-based learning anymore. It's about the gamified or gamification in education, or especially in teaching chemistry. So Dylan will talk more about the gamification. It's actually it's based on the game, yeah, the gamification approach, or something like gamified approach to learning. So what is gamification? He will explain everything related to gamification. Actually, gamification is not only playing games, yeah, it's not using only games, but everything that which is fun, I think can be included in our teaching and learning to support students' learning, to engage students, to motivate them to improve their motivation to study chemistry. So I don't want to make it longer. So just I will give it to Dylan to present his talk about the gamification in chemistry education. Please, Dylan.
Thank you, and good afternoon, everyone. Thank you for coming along. So I'm just sharing my screen, so hopefully we can see that on the screen now. Is that okay? Can everyone see that?
Yeah, it's clear now. Thank you. Yeah,
brilliant. Thank you. So as Erlina explained, we're going to be talking about gamification, and we're going to start off with an explanation of what gamification involves. And it could actually be a variety of different approaches to teaching we could technically call gamification. So I'm going to talk a little about that. And then I'm going to use 3 case studies from the University of Leicester to demonstrate different examples of gamification approaches that we've used in chemistry. 2 of those approaches are going to be based on a traditional card game format. And then the third of those approaches is quite different, because the third approach I'm going to describe will be an escape room. So it'll be a very different style of game activity. So we'll start off by talking about the role of games in teaching and learning in general. There's quite a long history of using these types of activities or using these types of experiences in education. And actually, if you look back in the literature, you can go back as far as Piaget and Vygotsky. They both highlighted the importance that play or games or fun play in the learning experience. So they both talked about that. And there are, I hope that there's a huge range of different types of educational game that exist, or playful experience that exists. And if you look at the Journal of Chemical Education, for example, it's not unusual to find at least one new chemistry game being published in every issue of Journal of Chemical Education. They're very, very popular, very common. They're very frequently used at school level. So here in the UK, we see games being used in school teaching a lot. However, they're less frequently used at university. So, for example, when I was an undergraduate student, it was completely unknown. We didn't ever use games to learn, but it is becoming more common now. And in the last maybe 10 years or so, we've started making more use of games in university chemistry teaching. And that's what I'm going to talk about. One of the reasons games are a lot more common now than they were maybe 20 or 30 years ago in universities is the advent of digital technology. So it's now quite easy for us to make games that can be played by students in a variety of different ways. So we might make a game that they can use for revision purposes, for example. So that might be a game that they can download on their phone and they can play it at home, or they could play it on the bus or the train as they're commuting into university. And it can help them revise the topics that they're learning about at the time before they do an assessment on that topic. So it could be something like a quiz, or it could be a puzzle that they have to solve that engages their thinking about the topic that they are learning. Now, the variety of learning games that exist take a number of different formats, and some of them might be individual games. So the things that I've just been describing there on a smartphone, that could be an individual game, a simple quiz or a puzzle like an online jigsaw or something like that. That could be an individual game that one person could play. But you could have a team game as well, where you play against someone. So it could be one player against another player, or it could be a group of players playing against each other, or it could be two teams playing against each other. So there are lots and lots of different ways that we can achieve this. And on the screen, on the right-hand side of the screen now, you can see a little image of a group of students at the University of Leicester. These are students from our foundation year a few years ago, back in 2019. And they're playing a game that we developed, which I'll talk about a little bit later on. It's part of a game called Spectroscopy Unlocked. And they're playing that as a team-based game. So you can see there's two teams in the picture there. There's one close to the wall, and then there's another team close to the camera. And there's 6 people, I think, maybe a bit more actually, maybe 8 people in each team. And what they're doing, they're focusing on a little board in the middle of the table, which you can just see there. It's a little colourful circle in the middle of the table, and they're playing a game as a team using that board to structure that game. And we'll talk a little bit more about what that game involves and how it works later on. So gamification is a very general term that we use in education, and it refers to us borrowing the mechanics of gameplay and embedding them in learning experiences. So essentially what we're doing, we're taking something that we would normally associate with being a game or a fun experience and moving that into a context where we wouldn't normally play a game. And typically the types of scenario that we would borrow game elements for and integrate them into would include education, which is why we're interested in this. So it could be school or college or university education. But it doesn't stop there. There are other sectors, there are other areas that are interested in gamification as well. And gamification is sometimes used in healthcare, and it has been used as a way to help people with their recoveries from illnesses, for example. So that could be physical or mental illnesses. it has been used as part of vocational training. So vocational training is training that people who work for companies would do. So training to develop a new skill they need for their job, for example. And there's an increasing demand for gamification in those types of experiences. And a lot of companies actually use gamification to learn more about their customers as well. So gamification is sometimes used to improve the marketing of products and to improve commercial strategies. So to get a better understanding of what motivates their customer base, what their customer base wants. So rather than doing a traditional interview or a focus group, they might get a team of potential customers to play a game and learn from that experience. So there's a lot of different areas where games are used as educational or training or research aids. So gamification has a number of different links on the way that we behave. So we'll talk a bit about why we might use gamification in a moment. I'll go a little bit more into the underlying theory of why we would choose to use gamification. But on a broad level, what we're trying to do is engage the participant in a different type of experience. So we're trying to take them out of the traditional learning context where they might be sat in a class and listening to someone speak, and we're trying to give them something very hands-on, sometimes very collaborative, where they're working with other people, and ultimately something very fun and very memorable that will help embed the core aspects of learning in their mind. There are different types of gamification, so there are different terms that we sometimes use in gamification. So one of those categories is called serious games. Serious games are usually video games, but they don't necessarily have to be. But they do tend to be video games more often than not. And they're used for educational purposes or healthcare or military or vocational training, etc. So if I want to take a very extreme example, I'll use an example that might be familiar from movies and things like that, but is not very educational related. The types of war game activities that the military would be involved in, where they play virtual war games, that's an example of a serious game. Now, we might use something along those lines in education. It might be a little bit lower stakes than the games the military are playing. And we might be giving students the opportunity to learn more about the lab environment they're going to work in by getting them to explore a digital lab environment. And I'm not going to say very much about that because that's basically the theme of my next talk that I'll be doing in a few weeks. So we'll come back to that. But that's one example of something we could imagine our students doing to help develop their understanding and also make them feel more comfortable and more confident when they go into the physical laboratory environment. Another term that we frequently used is game-based learning. So you might see this in the literature a lot. And game-based learning involves taking the mechanics of gameplay and embedding it into the way we teach our students and the way we get our students to learn. So that might involve integrating some kind of competitive element in the learning experience. So we might run a quiz and then we might award points for getting the right answer. We might even award points for the time it takes the student to get the right answer, so that in the end, we can classify their performance based on how quickly they got the right answer. And we can create a sort of league table, which shows how students are doing. So that's an example of a game-based approach where we're borrowing that competitive element, that scoring element, and we're integrating it into an existing learning experience. So if we think about why we might use gamification, why would we bother? Why would we actually change what we're doing to integrate game-based elements? What we're essentially trying to achieve is some kind of shift in the way the students are interacting with the subject material. We're trying to change the way the students are either thinking or acting with regards to the topic that we are teaching them. And we could break this down into three broad categories. And these categories are probably quite familiar. They're the same kinds of categories that we would consider, the same kind of domains that we would consider with almost any educational intervention. So we might be focusing on a behavioral outcome. We might be trying to encourage students to participate and engage in learning experiences. So imagine we have a very disengaged cohort of students. Imagine we have a group of students who we are having a lot of difficulty encouraging them to come to class. Or if they are coming to class, we're having a lot of difficulty getting them to listen to what we say and do the homework and do the activities that we set them. What we're trying to do with gamification is give them an alternative way of interacting and engaging, a more fun, more accessible way of giving them interaction with the subject. The other thing we might be trying to do in terms of their behavior is encouraging them to work with others. So we might be giving them a new way of discussing the subject with other students. And this might be something that if we didn't do it in a structured way, if we just said, okay, we're teaching you this topic, I'm going to do a PowerPoint on it, and at the end of my 1 hour lecture, I want you to have a 30-minute discussion with the people you're sat around about the topic, which could be acids and bases, or it could be organic mechanism or organic nomenclature, whatever you want. And sometimes that kind of discussion can be good. Sometimes you get some very productive discussion, but it is so ill-structured and it's so open-ended that for some students that can be a challenge. They don't really know what they're supposed to be discussing. They don't know how they're supposed to discuss the subject. Providing a game experience gives them a very structured framework around which they can discuss the topic. So if they're playing a card game about organic nomenclature, they can start asking each other, do they have, does the other player have a card corresponding to a carboxylic acid or an ester or an amide? And what we're implicitly doing, we're getting them to talk to each other and challenge each other when playing these games. But in order to have those discussions, it's essential that the student has a good mental picture of what a carboxylic acid is, what an amide is, what an alcohol is, what an alkene is. So it's a good way of getting them to relate their learning back to their interaction with others. Now, we might be focused on cognitive outcomes, the cognitive domain, by which we essentially mean learning outcomes or learning gain, if you like. And in terms of the impact that games have on individuals, essentially everybody who ever develops a game sets out to measure the learning impact. And this tends to be quite mixed. And this has definitely been my experience of it. Sometimes you could produce a game that has a very positive learning outcome, that has a very positive impact on student learning of the topic. And you can measure that outcome in a test, and you can statistically analyze it, and you can find a statistically significant benefit to the students. That's not always the case, though. And that's not necessarily an issue. If we can't demonstrate that benefit, if we can't demonstrate the learning benefit, then we might be able to demonstrate different benefits. But ultimately, the benefits that students, the cognitive benefits that students develop from playing these types of games are often difficult to measure. They're often things that you can't really measure with a traditional test or a traditional exam, because we might be having an impact on their criticality or their creativity, as well as their understanding of the topic. And those are typically things, creativity and criticality are things that are a little bit harder to measure than content understanding. The final domain that we might be focused on is the affective domain. And sometimes we group that together with the motivational domain as well. And one of the big motivators, one of the big drivers for us using games in education is to make students feel more positive about the subject, to change the way they feel about the topic or feel about the subject, and to try and develop their intrinsic motivation. So rather than relying on the extrinsic motivation of, I have to study this because I have a test in it in 2 weeks, what we're trying to do is change the mindset of the students so they think, I want to study this because I find it really interesting, or I find it really, really, really cool or really useful. So we want to develop that intrinsic inbuilt motivation where they want to study it almost for the enjoyment of the subject itself. We talked a little bit about this last week, that chemistry students, when they arrive at university, they do tend to have quite a high level of subject enjoyment, certainly compared to university students in general. In other subject areas. So gameplay can be quite a satisfying experience, especially for the winner, of course. And it can be, as well as being fun, it can be a rewarding experience. And it can pass the impact of the fun experience of playing the game can associate itself with the topic that we have based the game on. So the one thing that we don't know very much about at the moment is the kind of underlying psychology of how this works. So we've talked about these broad domains and the types of general effects that we are trying to have. But what we don't know is specifically what the game is achieving on the individual level. And there's been some quite recent research, and I had to go, this is outside of chemistry. This is more of a psychological study. It's been a recent study, and you can see the citation at the bottom there by Kraft et al. And they set out to do a meta-analysis of many, many studies of gamification and learning. They set out to learn more about how gamified learning transforms student experiences. And they came up with a number of broad areas. And what I've done, I've summarized these in this diagram on the screen here. So if we think about the benefits, I'll start at the top. We'll start with setting individual goals. So playing a game requires the student to have some kind of strategy, have some kind of plan. And in order to do that, they have to think very carefully about the situation that they're in and the environment that they're operating in. So they have to think about, who are they playing against? What advantages might they have, the players they're playing against? What weaknesses might the players they're playing against have? And how might they exploit that themselves? So it helps them think very carefully about planning a strategy based around this topic understanding framework. Gameplay provides immediate feedback. So in one way, shape, or form, games usually have a winner, especially if you want to publish in a journal of chemical education. You need to have a winner in your game. They often feed that back to us. And if you're going to have a winner in your game, then you immediately know whether you've got something, whether you've won or whether you've lost. There might be other ways you can provide immediate feedback as well. So you can imagine, if you do a quiz, if you design a quiz, you can set the quiz up so it tells the student whether they get the answer right or wrong. If you design a jigsaw puzzle, you're going to work out whether you've put the piece in the right place straight away, because if it fits, it's going to be the right piece. If it doesn't fit, it's probably not the right piece. It's probably the wrong piece. We have positive reinforcement. So we have that encouragement of topic learning, of subject understanding through the positive social experience of playing the game. There's also social comparison. Now, this is a really interesting one. This is the opportunity for the student to benchmark their attainment and their performance relative to their peers, relative to the people they're playing the game with. This is a really, really quite interesting aspect of gameplay, because it gives the students the opportunity to realize, are they amongst the best in the class? Are they in the upper quartile of the class? Are they average? Or are they actually struggling with the topic? Do they need to actually do quite a bit more work to bring their subject understanding up so that they're at a similar level to their peers? And that can be quite a useful thing. And it's something that our students often request. And in the UK, it's quite difficult for us to give them that information normally. We can't publish a ranked list of students' exam scores. We're not allowed to do that. It goes against UK law. There's data protection legislation in the UK that stops us from publishing a list of names with the exam scores next to them and putting them up on the virtual learning environment or putting that up on the wall of the building. You can't do that in the UK. What we can do, though, we get them to engage in these informal learning experiences that gives the opportunity to gauge how well they understand the topic compared to their peers. So it's a kind of proxy for what they've been asking for. The scaffolded nature of the games give students a series of guided tasks. And like I was saying earlier, the scaffolding that we impose by designing the structure and the rules of the game can facilitate student conversations and can facilitate student thinking when working through the topic. We also have this adaptive contexts facet. So we have this ability for students to apply what they know in a range of different contexts. And if we want to, we could design quite a complex game. So we could design a game where the environment that the students are working in changes very suddenly. So I was talking to a colleague yesterday. I was actually attending a conference, a virtual conference on chemistry education yesterday. And I was talking to a colleague I worked with some years ago. And he's designed a game based around the stock market. And it's the chemistry stock market game. So essentially, the motivation for the players is to buy stock in assets they believe will increase in value, much like the real stock market would work. And the challenge of the game that my colleague has developed is that the value of the assets will change. It will go up, they will go up, they will go down, and they will change over a period of time. And it's not done in a totally unpredictable way because the players are given news stories. So they're given examples of stories from the news that will inform the future share price of the assets that they're purchasing. So they might discover that some new legislature has been passed by the government, which is making it harder for the waste from a particular industrial process to be disposed of. That would have a negative impact on the value of the company generating that waste. So students would have to respond to those news stories by making sure they sold their assets in that company before the impact on the stock price was felt. We also have this element of multiple choice. So we're giving students the opportunity to choose a pathway through a game. And often there is no single fixed right answer for some types of games. So some types of games, it can be very flexible how students get to the right answer. And they can do it in a number of different ways. And sometimes it can be multiple different right or correct solutions. So that flexibility and that opportunity to have an individual path through a learning experience, that is very positively received by many students too. So there's a lot of different rationales for gamifying learning, and hopefully I've convinced you of some of the benefits of that now. Hopefully I've shown you that we know that this can, if done well, can have a deep impact on student behavior and on the affective domain. We can have an impact on the cognitive domain, but that's a little bit more tricky. And it's not necessarily a bad thing if a game we develop has minimal effect on the cognitive domain. If we can't measure a learning gain, it's not a major issue, as long as we're having a positive benefit on student motivation and on the affective domain. And if we can measure that, and if we can prove that, then we have succeeded in developing quite a positive learning experience. So what I'm going to do now, I'm going to show you 3 examples of gamified learning experience we developed at the University of Leicester. Oh, sorry, I'm going to show you this first. Sorry, I'm jumping ahead there. So these are examples of recently published chemistry education games, and these are not specific games. These are examples of games that you might see. And this is not an exhaustive list. This is not a comprehensive list of every game format you will ever see. But this is an example of perhaps some of the more common formats that we would see in the literature. So card games I will come back to because we've got 2 examples of card games I'd like to show you. We might have a board game. So we might have something a bit like a Monopoly style game, for example, where students have to work their way around the board and they have to generate some kind of reward. So that reward might be just completion of a circuit of the board, or it might be collecting some kind of currency within the game. They might be like Monopoly, they might be getting paid for completing certain activities like a successful pass of the board or avoiding jail or buying property and then charging the tenants. So we could adapt those kinds of classic game formats to work in a chemistry context, and that has been done by many people. We could be a little bit more ambitious if we wanted to. We could create a role-playing game. And some role-playing games are based on board games. Some of them are based on text-based prompts. Some of them are digital. And role-playing games require people to adopt specific roles within a scenario that is relevant to the subject that they are learning. And within this context, they will be interacting with different stakeholders in the scenario that they are working with. So you can imagine an industrial chemistry scenario where one person might be the supervisor. Some of the people might be workers on the shop floor of the factory. Somebody might be the managing director. Somebody might be the chairperson. And these people would all have to interact. And then you might get other people involved who represent different sides of the problem. So you might have government regulators, or you might have customers represented by some students, and they all have to interact in a given way. We could have video games. Video games are becoming increasingly common in chemistry education. So something that you could play on your smartphone, something you could play on a tablet device or a laptop that would be fun, that you could potentially play whenever you wanted to. You could maybe play it individually or play it against other people, and would give you an experience that would help you either learn the subject or have a positive experience associated with that topic area. And I know there are a lot of apps that are available that help students learn about the subject. Some are very general apps, some based on the kind of Duolingo format, where students answer lots of flashcard type questions on the subject. But there are others where the students have to do something slightly different, maybe something slightly more demanding. There are a number of escape rooms based on chemistry that we'll come back to later, because one of the examples I'm going to talk about is an escape room. And then the last example there is playful learning. And this is kind of getting at what Erlina was saying right at the start of the session, that this doesn't necessarily have to be a traditional game. So gamification doesn't necessarily mean it has to be a formal game with formal rules. It could just be some fun learning activity. And I know a number of universities in the UK make use of Lego Serious Play to help the students consolidate their understanding of different topics and to help give students an engaging, fun experience of the subject. So I know Imperial College, which you can see there's an image of a student working in the Imperial College lab there. That student is actually building a simple optical spectrometer using Lego pieces. And this is a standard teaching lab activity in some universities. I know Imperial College London uses it, and I know the University of Sheffield in the UK also uses it. But there are other types of activities like that. And actually, I was reading about some research that had been done at the University of Hull yesterday, where the investigator was trying to learn more. The researcher was trying to learn more about how their students were sitting their remote exams. So during the COVID pandemic, students have been taking exams from home, and they wanted to learn more about the working environment the students had set up for them when doing those exams. So they got the students to build a Lego model of their room that they were working in, where their desk was, where their computer was, where their drinks were, where their lights were. And then they got the students to critique those models and say, well, reflecting on that, now you've seen this model of it, what do you think you could improve about that? And that's not a game, but it certainly qualifies as gamification for me, because it borrows the game-based elements, game mechanics, and is being done in a style that we would describe as playful learning. Right, so I'm now going to come back to some examples then. So I'm going to start with a card game. We've got two card games we're going to look at. This is a card game based on organic chemistry, and it's based on the classic card game called Go Fish, which is very popular across the world, especially in the US, very popular in America. And what we did, we took the game and we played about with the name slightly. So you notice we didn't call it Go Fish, we called it Go Fisher. So we took the name Fisher from organic chemistry, so the famous organic chemist, mechanistic chemist, and we embedded it into the name just to show that this has an organic flavour, but also to reflect the fact that it is based on the classic goldfish format. So this game is designed to help students learn introductory organic chemistry. And the idea is that students learn how to name organic molecules, and students learn how to represent those molecules in skeletal formula, and students know how to recognize functional groups. So there's a few different things, there's a few different learning outcomes that we're working on when we're getting them to play this game. And just as a little aside, this is not an important aspect of this, but I have to tell you that this game was originally developed by some of our first year students when they were working on our CPBL activity right at the start of their degree. So when I told you about the Learn on the Move activity last week, it was actually a team of students working on the Learn on the Move activity that originally developed this game. So there's a little bit of a link back to what we talked about last week. But back in 2017, back 5 years ago now, one of our groups of first year developed this game called Go Fisher, and it was a prototype version. It was a little bit rough around the edges, as we'd say in the UK, so it needed refinement. There were a few mistakes in it. The rules were a little bit inconsistent, but at the heart of it, it was a really great idea, really great idea. And you can see some examples of cards on the right-hand side of the screen there. So you can see some cards with names of functional groups on them. So you can see alkene, for example. You can see that's a blue card. So any of the blue cards have a functional group on them, name and formula. The red cards have an example of a reaction on them. So you can see that one is alcohol plus haloalkane or halogenoalkane, as it's been written out there. And there's a blank on there. So you can see that the students playing this game, they have to fill in the blank. They have to work out what that blank is. The yellow card is the name of a specific molecule. So it's an example of a specific molecule that would have the functionality it matches up to the blue suit and would answer the mechanism blank in the red suit. And then the green card shows an example of a formula. So it shows a skeletal formula. And to get a complete hand of cards, to get a full a clean sweep of cards, the students would need the functional group, the mechanism card, the molecule card, and the structural representation card, and all four of those would have to map onto the same molecule. So it would have to be, the functional group would have to describe the functional group present in the molecule, the structure would have to be the same as the name, and the name would have to correspond to the blank in the mechanism card. And if they did that, if they achieved that, then they had a full house of cards on that for that particular molecule. So Go Fisher was, like I said, it was originally developed in 2017. It wasn't quite in a stage where we were ready to publish it because it needed some improvement, needed some enhancement. So in 2018, we allocated this particular game to a group of our undergraduate project students. So these are final year undergraduate research project students. And we asked them to test the game out themselves, to develop a robust set of rules, and then to do a pilot implementation with a small cohort, and then to do a full implementation with a larger cohort. And we were quite lucky at Leicester because we had what we call a foundation year. So a foundation year in the UK, it's quite common in universities that teach chemistry. It's an entry point for students that don't fulfill the normal entry requirements for a chemistry degree. So at Leicester, let's say the entry requirements are at the A level, we require students to get something like an A and 2B grades. And let's say the student has unfortunately not done as well as they wanted to in their exams, and they ended up getting a B and 2 Cs. Well, we wouldn't normally let them into the first year of our degree because they haven't met the entry requirement. But what we might do, we might offer them an alternative, and we might say you can join our foundation year, which you can think of as being basically a year zero. So it's an opportunity for students to learn the topics they should have learnt at school before they start year one of our programme. It's an opportunity for them to come and do that at university. So we have a foundation year cohort at Leicester, and that cohort consists of around 20 students typically each academic year. So it's quite small. It's not a big class, just 20 students in the whole year group. And we decided, because of the basic learning topics of this game, because the learning outcomes were quite simple, we decided it was quite a good match for what our students in the foundation year were learning. And we thought, because it's quite a small group, it'd be quite a good pilot implementation. We could divide the foundation year essentially into 3 or 4 small teams, and we could get each of those teams to play this card game and then give us some feedback on it. So we ran a simple version of the game, a basic, easy to play version of the game with the students in the foundation year, collected some data, and then ran a larger implementation with our first year students. We wanted to make the game as adaptable as possible, though. So we actually made an advanced version of the game, a more difficult version of the game. And in the more difficult version, rather than playing as a team, students play as individuals and they play against each other. And they receive a little bit less support and a little bit less structure than the students in the first year do and the foundation year do. So the picture on the right-hand side, you can see 2 people playing against each other there. They look like they're comparing, they're looking at a hand there. So it looks like one of them is claiming that they've won and the other player is verifying that that is correct. Now, this is the student on our left, as we look at that, he's called Tom. These 2 students were actually in our 4th year of the undergraduate program. They were in the final year of the program. So they had studied organic nomenclature quite a long time before this. They were helping us with the piloting of the project. They were playing the advanced version of the game and giving us some feedback on that advanced version, just to show it was it had a bit of flexibility. They fed back that this was a really good revision experience for them before they did their final exams at the end of their degree course. So the actual full pilot of this was run with our foundation year. The foundation year had 23 students in it in the 2018-19 academic year. And the idea was we wanted to measure the impact on student understanding. We wanted to measure whether there was any tangible impact on the cognitive domain. So what we did, we developed a pre and post test, and we did this all in a single session. So we had a 2-hour-long session with these students. We got them to do the pre-test first of all when they arrived. They played the game, and then shortly after they took the post-test. And this was all done in a single sitting, essentially. It was all done in a single session. The participants were also given a questionnaire, and that questionnaire was designed to measure the motivational and affective domains. It was designed to measure the impact on those domains. So the pre and post test focused on the cognitive, the questionnaire focused on the affective and the motivational. And then to follow this up and to get more substantial detail, we ran a focus group a short period after the activity happened. So we ran a focus group the following week. And on the right-hand side of this screen, you can see the example of the rules that were developed for this initial pilot version of the game. So you can see there's lots of pictures in those rules. We're giving the students a lot of structure to work around. We're giving them an example of what they should be looking at. And you'll notice that the text is broken down steps. There are 4 different steps there. So the first step, review the cards in your hand. Do you have any complete sets, or do you have any almost complete sets? And we give them an example hand in the picture. And in the example hand, the alkene set is almost complete. They are missing a card. They need one final card to make to have a full set for alkene. So it's then the player's responsibility to go take turns going around, asking if they have any cards belonging to that set. The player we are looking at here in this particular set of pictures, if they ask for alkene cards, then the players on the other teams would have to hand over their alkene cards. So once they've handed over those cards, you review the set again, and if you have a complete set, you can then place them on the table and say "Go fish," and say "Go fish," and then that scores a point for that particular team. So it's a very familiar game format. It's based on a classic game that students will have typically played before coming to the university, but we're doing it in a chemical context. So we've given them a subject-specific context. But we're scaffolding this really carefully, giving them step-by-step instructions and giving them lots of pictures to help them work through this. And we made this available, this set of rules available online in advance, and we also gave them printed copies on the day they played the game. And when we evaluated the pre and post test, what we find is that there's actually no real impact on student understanding. So about half of the students got exactly the same score that they achieved before they played the game. And then the rest of the students, they split between students who improved their score slightly and students that decreased their score slightly. However, the standard deviation of the mean is very, very small, and there's no statistically significant difference between the post-test average and the pre-test average. So statistically, there was no real impact. In absolute terms, slightly more students got better scores than worse scores, so I suppose we can take some consolation from that. But in reality, we can't really claim that this particular card game had any statistically measurable impact on the cognitive domain of the students in this pilot group. However, what we decided to do then was to look at their responses to the Likert statements, and we actually decided to break this down based on whether they performed better, worse, or no different in the post-test compared to the pre-test. And what we found straight away was that the students who did worse generally rated the difficulty of the game higher than students that did better. So you can see 0% of the students who improved their performance rated the game difficult to play, whereas 25% of the students who performed worse rated it difficult to play. So that was quite important to us. In terms of understanding of the objective, 50% of the students whose score in the post-test decreased compared to the pre-test reported they didn't understand the objective of the game. So only 50% of them understood it. The other 50% didn't understand. Whereas for the students who improved or had no change, they essentially scored around 90% for that. They understood the objective. The same thing happens with the rules. So the students whose scores improved, over 60% of them understood the rules, whereas for the students whose scores decreased, only about 25% of them understood the rules. So this suggests we need to be very careful in terms of how we communicate the rules and the amount of time we give students to familiarize themselves with the rules before they play the game for real. Prior experience with educational games might be a factor in this as well, based on this data, because you could see the students who did worse, about 3/4 of them had played educational games before, whereas the students who did better, you could see that essentially all of them had played educational games before this one. So when we reflected on this small scale pilot with the foundation year, we recognized that some students found the rules difficult to follow. So we set about updating the rules to make them more accessible. And we tested these out on a pilot, on a focus group. So we recruited a focus group from that same cohort and we showed them the new rules and we got feedback from them and it helped us to revise them. We also noticed that an initial lack of topic understanding was a barrier to learning. So if the game is played before the topic has been comprehensively covered in lectures, this seems to be an issue in terms of in terms of cognitive benefit. However, we did notice that students were very positive about the overall format of the game and the experience of playing the game. So the effective factors were very positively rated. So when we rolled this out for the larger scale implementation, we ran it with 55 year one students. So this is at a different level now. This is a level higher than the pilot group. And this new revised version of the game had an improved set of rules, a slightly redesigned set of cards, and otherwise, the implementation was run in exactly the same way as it was for the foundation year. So we used the same questionnaire, we used the same pre and post test as we had with the foundation year cohort. So we tried to keep things as comparable as possible. And on the right-hand side here, you can see an example of some players playing the game. And I can actually, even though you can't see her face, I can tell you that the student with the stripy top on at the far end of the table, that is actually the first name on the author list. That's Georgia, who is one of our project students who was leading this. And although I can only see the hands, I'm guessing the other student on the right-hand side of that picture is Corey, who is the other undergraduate student who was working with us on developing this. So when we ran it with our first year cohort, when we ran it with our 55 students, we did the same kind of pre and post test again, and we found exactly the same thing as we did with the foundation year. There is no statistically meaningful learning gain from this intervention. There's no detriment either. It results in essentially, within statistical uncertainty, the same mean and standard deviation before and after. So you can see about 50% of them students, the score stayed the same, and then the remaining students are split perfectly evenly between those who improved or got worse. Very, very tiny proportion greater improved than got worse, but it's no difference really. When we looked at the Likert ratings, we were quite pleased that some of the changes that we made seemed to have some really tangible benefits in the responses we were getting from the students. So when we looked at the difficulty rating the students were given, so the game difficult to play, we're now looking at all of them rating that at under 40%. Interestingly, the students who did better in the post-test actually rated that were the ones who scored, gave the highest rating for difficulty. Which is very interesting and probably converse to what you would expect. In terms of understanding the objective, so scores of kind of mid-80s for the cohorts, the parts of the cohort whose scores stayed the same and those who got worse. For the ones who improved, that it was only 60%, interestingly. Again, that's quite an odd outcome. The rules were easy to understand and follow. So good ratings for those students whose scores stayed the same and those who improved. Little bit low for the students who didn't understand, but higher than it was in the original implementation, which shows those changes to the rules had kind of paid off, had given some benefit. Enjoyment was fantastic. It was 80% or greater for all of the students, and experience playing educational games. Interestingly, for this particular year group, it was over 90% for all of the students who played it, which is quite different to the foundation year. So our key findings from this experience, this game, oh, hello, sorry, show you the key findings before I move. The key findings from playing the game, students enjoyed playing the game. It was a positive, fun experience. Our observation was it was a very lively, engaged learning session. The pre and post-test performance of almost half the participants was not affected by playing the game. And then we have between 27 and 35% of players improving their performance, depending on which cohort we looked at. But actually, statistically, the performance was identical before and after for both cohorts. Getting a set of rules that work is really, really important. And actually scaffolding that gameplay properly is critical. Students fed back that they enjoyed the competitive nature of the game and they enjoyed the social aspect of the game. So this is feeding into that affective domain. And we also picked up that a lack of prior understanding of the topic is certainly a barrier to success in the game. So it suggests that this type of game is most effective to reinforce something that's already been encountered in a different context, rather than using it as a way to introduce an entirely new topic. Okay, so the next game I'm going to present is another card game, and it's one that Erlina might recognize. It's called Prediction. This is an inorganic chemistry game. We call this prediction the VSEPR game. And this game is based on addressing a common area of misconception in the understanding of general and inorganic chemistry. So students are known, many students are known to have difficulty in developing effective mental models of some threshold concept in the subject, which they will need for their further studies. And determination of three-dimensional molecular structure is one of the most commonly reported misconceptions in the literature. So the ability to use a simple theory like VSEPR or Nyholm-Gillespie theory, if you prefer the old name, that is an example of a concept that students often find difficult, and then representing that structure in 3 dimensions, something students frequently find challenging. So we set about doing something about this by designing a supportive learning game, giving them the opportunity to work with others and to do something tangible and hands-on. So this is a 2-phase game. And it's partly based on a card game element, but that card game element is supported and complemented by a model building activity. So students actually build molecular models based on the molecules that they have been learning about in the card game itself. And you can see on the right-hand side there, we've got an example of the first card, the title card from the card game at the top. And underneath it, you can see some examples of some molecular models that the students have been building. And it looks like we've got maybe some water and some maybe BF3 there. So we've got some examples of different common structures that students might encounter at this early stage. So in terms of the aims of this intervention, first aim was to design and develop a game and a model-based activity to address this known misconception. And the second aim was to evaluate its effectiveness as a learning tool and to think carefully about how students were interacting and engaging with it. Sorry, the postman has just put something through the front door. It's very distracting. So in terms of the research methods that we used, the instruments that we used to evaluate and measure the impact of this intervention included a questionnaire, a concept test, which students took before engaging with the activity and then again after the activity, and an interview guide. The participants, you can see this is an international study, and participants included instructors and first-year students at your own institution in Indonesia, which is fantastic, and also students on the Natural Sciences course at the University of Leicester. So that's another fairly small cohort, a cohort of about 20 or so students who study essentially combined sciences. They study a general science degree that includes chemistry, biology, physics, and some other aspects of other scientific disciplines. So the research methodology is summarized by the cycle on the right-hand side, which includes a planning phase where the resource was designed, an action phase, which is the actual construction and development of the resource itself, an observation phase where students engage with the activity and they were observed, and then a reflection phase where the data collected was analyzed. So the card set that was developed consisted of 36 individual cards, which included some cards like the cover and the learning objectives and the rules. So they weren't all playing cards. Some of the cards were there to help students understand how the game worked. We also gave them some definitions and introduction to the theory, so they could refer to these as they were playing the game. The questions on the cards themselves, the gameplay cards, they were based on some example molecules. And students worked in pairs to answer these. And when the students worked their way through a particular example, when they got to the completion and they successfully worked out the structure of the molecule, they then built a model of that molecule. And we did that in a relatively simple, accessible way using polystyrene balls, cocktail sticks, and map pins. And this is a game and activity that was developed by Erlina, and a lot of work went into this, didn't it? A lot of work, a lot of effort went into this. I remember we had a lot of fun testing things out and building some of these models and playing with it. But it was a really, really great experience for us as well as for the students. I think it was really worthwhile.
Yes, of course.
Yeah, brilliant. And I think the format of the model was great because it didn't require any expensive components. So it made it very accessible for anyone to play with it, really, because the materials used were very cheap, very easy to reproduce, which allowed students in a range of different contexts to build these models. So you can see examples of some of these modeling kits here. And you can see they're essentially these different colored polystyrene. You colored those spheres in, didn't you? You have to paint them or something. Is that right?
Yeah. Yes.
And then what the students playing the activity do, they stick the little cocktail sticks in to represent the bonds between the atoms. And then you can see in the example on the left-hand side, which if I'm remembering, I was going to say, if I remember my inorganic chemistry right, that's ammonia. And then I can see it's ammonia on the left-hand side of the screen. So it's actually there, isn't it? The answer's on the screen. So ammonia, the central nitrogen has a lone pair of electrons. And that lone pair is represented by two MAC pins that are pushed into the nitrogen. And that essentially represents the two electrons localized on the nitrogen atom rather than forming a bond pair. Then the example on the right, so we've got BF3, we've got boron trifluoride. And in this example, the boron's group 13, so it has no lone pair of electrons, so there's no MAP pin this time. And you can see the structure is different. So hopefully everybody's familiar enough with VSEPR to recognize why. So we just have the 3 bond pairs and 0 lone pairs this time. And to maximize repulsion, we adopt that trigonal planar geometry. And in the literature, this is something that students have a lot of difficulty with, because when some students in introductory courses look at NH3 and BH3, they find it difficult to understand why those have different shapes, why those have different molecular structures. And this is a really nice way of illustrating that and giving them a hands-on activity where they have to build those models to see that. So in terms of what the cards had on them, this is an example. This is a contents list. This is actually from a J.Chem Ed publication that we had on the paper. Sorry, when I move slides, because I'm trying to move the camera thing across and I accidentally hit the slide. The examples of the cards, most of the cards are question cards. And you can see what the question cards are trying to achieve. They're trying to give the students a scaffolded run through of VSEPR. So we're trying to get them to work through the stages of the VSEPR process, starting by working out what the central atom is, working out what the total number of electrons, how many of those are valence electrons, how many valence electrons do the surrounding atoms contribute, then thinking about how many pairs, what structures has it got, what shape has it got, and then once they've done that, they answer they build the model. And the really clever thing about this game, and I have to entirely credit Erlina for this because it was a really clever move. If the students get the answer wrong, they get a hint. They get a little hint to indicate what they might have done wrong, to encourage them to think about that step again and to maybe have another go and get that right. So we have correct answer cards that congratulate the students on getting the right answer, but we have wrong answer cards which give them feedback, give them hints. Going right back to the start of the talk, that's that immediate feedback, which we know students value in games. So the evaluation of the activity was conducted by means of a Likert study. So 8-item Likert tool used for doing this. And it was measured on a 5-point traditional 5-point Likert scale with a neutral score. So these are students on the chemistry education program, 20 responding to this. What we can see is the strongly agree are the kind of light blue colors and the purple color. And for every single question, every single statement, there is a really strong level of agreement, to the point where that agreement is 100% in many cases. So for example, the instructions are clear and understandable. 100% of the participants agreed with that statement. And I enjoyed doing the activity. And the presentation of the activity card is interesting. and the molecular model was useful. Again, 100% of respondents agreed with that, which is a phenomenal result. That is an exceptionally good result. So you can see this was a really valuable experience for the students participating in it. And like I said, we set about measuring the cognitive domain as well by means of a pre-test and a post-test based on this was based loosely on the Mulford and Robinson chemical concept inventory test. And this is very different to the other example of a card game I showed you earlier. This time there was an exceptionally strong learning gain that was very statistically significant. So there was a 25.7% average increase in score between the pre-test and post-test. So an absolutely phenomenal increase in score. When this was analysed by t-test, you can see that this is a very statistically significant result at p equals 0.001 level. So you can see this is a really, really statistically robust result, showing the value of this game in terms of the cognitive, motivational, and affective domains. So really, really successful intervention. So the activity helps students understand the basic concepts of predicting shapes of molecules. It helps them visualize those molecules in 3 dimensions by giving them a chance to build them. And it also gives them a very positive, fun, and engaging student experience. So we're having a very positive benefit on how students think about general chemistry and how students think about inorganic chemistry. We're also giving them a really great social learning experience where they talk to each other about the subject. So that is a really wonderful example of a learning activity based on gamified elements that we've very successfully used at Leicester. And actually, this is something that we do still use both of these games, by the way. We do, and I say we, I keep referring to we, even though I don't formally work at Leicester anymore, but Leicester does still use both of the game activities, usually with the first year students, usually very early on, but they've been very successful, and they're things that we do really, really value. So the last example I'm going to show you is something very different. This is an escape room activity. This is maybe a little bit less developed than the 2 card games that I've shown you, but it was a lot of fun, and we did get a really good pilot group testing it out. So I wanted to show you an example of something quite different. So as a school, it's a little bit confusing. We call ourselves a school. It's a department, basically, a department of chemistry, but the university calls us a school rather than a department. It's just the language the university uses. But as a department, we do lots of what we call widening participation. Widening participation is where we develop chemistry activities to encourage people who might not normally be involved in the subject to become interested in chemistry. So we might go out to local schools and do these activities, or we might go out into the community to do these activities. And the idea is we want everyone to have access to the subject. We want everyone to have the opportunity to study and do chemistry if that's what they want to do. So we set about designing a new activity that we could take out to local schools, and we were going to run this with students aged between 16 and 18 years old. And the focus of the outreach activity was the topic of spectroscopy, which in the pre-university curriculum is a very, very important topic, something that is a lot of focus, a lot of emphasis is placed on. And we know from our experience as university educators that a lot of students who study this at school actually struggle with it. When they arrive at university, they often have some misconceptions. So the students, this was done as a collaborative project between 2 students and 2 staff. So the 2 students were final year undergraduate research project students, so much like the 2 students who helped us with the card game earlier. But what we decided to do here, we wanted to give students essentially full creative control of the activity. We wanted them to be responsible for the format and design of the game. And the reason for that was the need to produce something that was relatable to 16 to 18-year-old students. Our final year undergraduates are typically 21 years old, roughly. So they're about 3-4 years older than our target audience. The staff involved in this, I won't say the ages, but they're much older. And it is quite challenging for us to empathize with what would motivate a 16, 17 or 18-year-old student at school. It's very difficult for us to empathize with that. So we wanted to use the fact that we had 2 student partners working with us who were much closer in age to our target audience to help lead the design of the resource. So we were totally open-ended in terms of the 2 staff members working on this, which was myself and my colleague Barbara Villamarcos, who's now at the University of Nottingham. We were completely open-minded about the format that this would adopt. We were there to act as in an advisory capacity and to help with the logistics of arranging the activities, but we didn't want to intervene too much. We didn't want to be heavy-handed and say it must work in this particular way and it must work in that format. So very, very early on, our 2 project students decided they were very keen to run an escape room format. So escape rooms at the time, about 2018, 2019, they were extremely popular in the UK. And these are essentially real world puzzles where participants will typically pay to spend a period of time locked in an environment where they have to solve a series of mini puzzles, which will help them generate clues that will unlock the room and let them out. So the idea is it's a challenge against time where the players have to solve all of these many, many challenges or mini puzzles, and eventually they will get the key and they will get their way out of the room if they're successful. If they're unsuccessful, then they will run out of time and they will just be ejected from the rooms by the owners. And there are lots and lots of commercial escape rooms. It's not as popular as it was 3 or 4 years ago, largely because of the pandemic. And obviously when social distancing was in place, escape rooms weren't allowed to open. In the UK, we don't have social distancing anymore, so they can open again now, but people are still a little bit hesitant about going back to that environment since COVID. So they're not as popular as they were a few years ago. What we asked our students to do was to think about what precedent there was for developing educational escape rooms. And what we were pleased to see is there were some examples in chemistry already. So there were some chemistry escape rooms in the literature. So Dietrich et al. Published a J.Chem Ed a few years ago describing a chemistry-based escape room. Very different to what we had in mind, but format-wise, it shared some of the general features that we hoped to build into ours. So why did they choose an escape room? Well, our 2 students loved escape rooms. They used to play them in their free time. So they used to go into Leicester City Centre, and there were many different escape rooms in former shops in Leicester City Centre, and they used to go and play these different escape rooms because every one of them was individual. Everyone had its own set of challenges. And they convinced us, even though myself and my colleague had never played an escape room before, they convinced us that this would be very fun, engaging, and it would be a really great way of getting students to work in teams and to collaborate together. Because escape rooms only really work if you have a very close-knit team that work very well together. What we wanted was to design something that would require students to build a team of about 5 or maybe 6 players. So rather than using the existing educational games where students usually either work on their own or they might work with 2 people, might work as a team of 2, we wanted something where they might work in a team of 3 or 4 or maybe even a little bit bigger and collaborate on solving those problems, solving those challenges to get out of the escape room. So the aim was to provide students with the opportunity to apply their understanding of spectroscopy to solve a number of small challenges that would help them unlock the room. So every time they solved the challenge, they would get a clue. And then when they had all of the clues, they could work on putting them together, and that would give them the combination to the lock that would help them get out of the room. So they have to work very well. They have to collaborate effectively. The problems are very open-ended in nature as well. They can be solved in a variety of different ways. and effective communication is really, really important. So it's important that they talk to each other, they come up with a strategy, and they plan their time, because they're doing this against the clock. So in terms of the format we adopted, we broke the activity down into 2 sub-elements. The first element is called Spectroscopy Unlocked, and the second element was called the Chemistry Escape Room. So Spectroscopy Unlocked is actually a classroom-based session. And it was a 2-hour-long session where students met the teams that they were going to be working with in the escape room, and they played a number of mini games based on spectroscopy. And the idea was, this was a team building activity. This was to get them used to working with each other, and working with each other within the context of the spectroscopy topic. The escape room followed 1 week later, and the escape room was set in the teaching laboratory of the School of Chemistry at the University of Leicester. The students were guided in the escape room by the 2 undergraduate project students, and there were also the 2 staff members present for safety oversight. The undergraduate students were there largely as guides. They weren't there to direct the students. They weren't there to solve the problems for the students themselves. So the classroom session, you can see the pictures here. So the bottom picture we've already seen. It's the one I described earlier. They're playing this board game in the middle of the table, and then we have another view of the teams at the top there, all kind of huddled around discussing something. And the idea was, we used, yet again, we used our foundation year as the pilot group for this. So this is our year 0, or our foundation year of the degree program. It consisted of around 20 students, approximately. We'll see exactly how many in a second. I've forgotten what the exact number is. And these students were working together in this classroom session to learn more about the topic, but also to learn about their team and to think about how best to work with the other people in their team. So we refer to these games as icebreakers, and that is a term that we use to describe any activity that helps people get to know the people they're going to be working with. So we do icebreaker activities at the start of any group work, just to get students comfortable working with each other. And icebreakers are normally fun, short activities. They can be games, they can be little tasks that the group members have to do just to kind of introduce themselves to each other. The escape room activity, like I said, it took place in the teaching laboratory. So you can see the 2 pictures on the right-hand side. The first picture, that is actually our spectroscopy suite, which is, oh, actually, no, they're just outside. The spectroscopy suite is through that window there behind them. So they're actually in the main part of the lab. You can see they're studying something very carefully there, but I don't know quite what that is. They might be preparing a sample to run on the UV vis spectrometer, or possibly on the infrared spectrometer. And then at the bottom, you can see a pair of students, and I think the one on the right looks like she's holding a TLC development jar there, which I think one of the clues was chromatography based, even though this is a spectroscopy activity. So we did cheat a little bit there by having chromatography included in it. I think they had to separate out an ink sample, and it was the order in which the colours appeared was the clue, I think. So this took place after the classroom-based sessions. Students knew who they were working with. They had done these icebreaker activities and got to know each other quite well. The lab session started with a short briefing, a short introduction, if you like, which was given by our research students, by our project students, and this was to contextualize the activity. So they were given some prompts and context that adopted the CPBL style. So we actually gave them some fake newspaper articles, which gave them the context of the activity that they were going to be working on. The escape room activities themselves, like I said, there's a number of mini challenges the students must participate in. These included code breaking, analysis of spectra, and a few hands-on experiments, which included the TLC, which you can see the 2 students doing there. So This is a really great way in getting students to think about spectroscopy and to apply spectroscopy to problem solving, but we also used it to help give the students more experience of laboratory chemistry and to give them an example of doing experiments to solve a problem, which at foundation year level, they don't really do very much of. They don't have much laboratory time, and when they are in the laboratory, they're generally just following instructions rather than doing open-ended tasks. So this summarizes the topic learning outcomes that the students were working on. So they got to use the infrared spectrometer, and when they generated the infrared spectrum, they had to use it to identify different functional groups present within the sample they'd analyzed. And they had to do a word search. They had to do a little game similar to a crossword where we give them a grid with lots of letters in it, and they have to look for the words related to spectroscopy in that word search. They had to do a thin layer chromatography separation of a mixture of colorful compounds. I think it was an ink sample that we gave them. And then that tied in to a number combination activity. Then when they had done that, they moved on to an NMR activity. So they did a simple coding exercise, which wasn't necessarily, it wasn't heavily chemistry themed, that coding exercise. It was a kind of classic coding exercise that you would get in an escape room. They had to match spectra to the relevant organic compounds. They then had to use a wheel to kind of decode a message. And then they moved on to the final element, which was mass spectrometry. And for mass spectrometry, they had a short exercise based on time of flight mass spec to do. They had to rearrange some equations. That equation generated, by doing that, it generated a code. Then they were given the code that would unlock the box. They had to find the box, unlock it, and get the prize out of it. And then they had completed the escape room. So we had 24 students complete this in our foundation year cohort. We evaluated it using a 5-point Likert. So we asked students, did it help reinforce their previous knowledge? And they were very much in agreement with this. We had 22 out of 24 students agreeing that it helped to reinforce their previous knowledge. And we also asked them, was the escape room enjoyable? And all 24 participants agreed it was either strongly agreed or agreed it was an enjoyable experience. So again, that effective benefit was very strongly felt in the responses to these questions. We ask students about teamwork as well, because teamwork is often something that is a little bit trickier to get consensus on from our students sometimes. So we asked them whether working as a group helped them learn more about the topic. And again, there was a very positive response to this. So we had 21 out of 24 participants either agreed or strongly agreed that the teamwork element was really important and helped them learn more about the topic. So we also got some qualitative feedback. We also asked students to give some opinions on the experience of doing the escape room, and they were very positive about the use of games in the classroom, and they were really positive about the work that our undergraduate research project students did to guide them through the process. So they thought the level of engagement from our undergraduate facilitators was excellent. The participants suggested some more improvements that we could do in the future. So they asked for more clues to help them solve the puzzles. And they also asked for more prizes. So they suggested instead of just getting one big prize at the end, perhaps we should reward every stage of the process. Perhaps we should have a small prize for every small activity that they have solved. They also fed back that they would have liked to have done something that involved chemical synthesis in the lab. So we were getting them to do a lot of analytical techniques and a lot of spectroscopic techniques, but some of the students fed back that they wanted to actually make a chemical compound in the lab. Now that's a different type of challenge, because that generally requires a lot more time than giving a student a sample and asking them to run a spectrum on it. but it is something that we could potentially build into a new escape room activity, but maybe one that has a slightly longer timescale to give them enough time to make the compound and then do the analysis at the end. They also suggested that we might want to consider running the activity with smaller group sizes, just to ensure that everyone has the opportunity to make a full contribution to the experience. Now, the students themselves, I'm absolutely full of praise for the undergraduate students who put this activity together. And on the right-hand side of the screen here, you can see the students publicized the activity with posters that they put up around the chemistry department. So you can see you've got this Can You Escape Chemistry Escape Room poster. This was a really brilliant advertising campaign. And we had students in all of our years asking, could they play this game when they saw this advert? And we actually had staff ask, could they play the game as well? Because they were so excited about these posters that were appearing around the building. The photo underneath that, the picture underneath that, you could see a group of our foundation year students. This was the winning team, actually. This was the team that completed the escape room in the shortest time. I'm delighted to see one of my personal tutees is in that photo as well, a student called Frankie, who was one of my tutees. So a bit of personal pride there for me. And one of their prizes for completing this was that they got some fancy dress and an opportunity to take some quirky photos, team photos at the end, and that was their team photo that they took at the end of the activity. So we didn't actually do any work on the cognitive domain for this particular activity. It fell a little bit outside of the scope of what we were trying to achieve here. We wanted something that was suitable for engaging with local schools. We weren't necessarily prioritizing the learning of spectroscopy. What we were trying to do was to change perceptions about chemistry, change perceptions about spectroscopy and analytical chemistry, make them more positive about those experiences. So we focused on an effective evaluation. Unfortunately, this happened just before the COVID-19 pandemic. So as a consequence of that, we never really followed this up. It happened once and it was essentially never repeated. It's something that I do hope I can bring back at the University of Birmingham in the near future. So maybe something for next academic year at the University of Birmingham. But yes, it's kind of been mothballed, this, unfortunately, due to the pandemic, and partly due to the fact that I've moved to another university since then, and so has the other member of staff who was working on this. So, here are our key lessons that we've learned from this then. So we learned that the escape room was a brilliant way of giving students a very positive, enjoyable experience, and giving students an experience that helped supported their learning of a core topic in chemistry, and something that is really important in that pre-university curriculum. That was something that we knew we had to have. We had to play on student motivations. We also have to play on teacher motivations. So if we want to run this in schools, we have to demonstrate to the teachers who are giving up time that this is relevant to the curriculum. This is relevant to what they are teaching their students. The only way we can do that is to align it with the pre-university curriculum. So the escape room format itself was a really effective way of supporting teamwork and getting students to work together collaboratively in that chemistry teaching laboratory environment. We recommended some small format changes before we actually took this out to local schools. Now, we never actually did this because of the pandemic, but if we were to do this in the future, we would consider maybe adjusting the group size, maybe reducing the group size slightly, maybe including more clues, and maybe doing what the students ask for and include adding more prizes for the various different stages of the problem-solving process to build up that motivation. We also considered whether we could broaden the topic scope of the activity out and whether we could include some additional topic areas. And this is something I think we were very positive on. Like I said, if we wanted to do chemical synthesis, we'd probably need more time than the short escape room that we run with these foundation year students. But we could certainly build in other aspects of chemistry into a 2-hour session, and we could maybe consider doing a longer, maybe 3 or 4 hour escape room activity that included some synthesis as well. So I think probably I need to leave it there, don't I? I've got an entirely other section, but what I'll do, I'll keep that up my sleeve until next week, if that's okay. Because I can see we're at with 25 minutes to go. I guess we need to go to questions, do we?
That's fine. If you want to leave it till next week, I think it's yeah, it's quite good to discuss about it later on.
Okay, brilliant. It's a good topic to come back to at the end, actually, because it comes back to a question I got asked last week about what happened during the COVID pandemic and how did we deal with the situation. So I'll talk about that when we talk about, it's not next week, is it? In a few weeks' time, I mean, but in the next session. That's what I meant to say, not next week.
2 weeks later, yeah. Okay, I think that's all, Dylan.
That's it. Yeah, you feel free to open it to questions. Yeah.
Okay, thank you so much for the interesting talk. I think it's always interesting. It's always fun to talk about the games and what is the role of this game to learning. I remember when I was attending the conference in Edinburgh, I think, STEM conference, I think, yeah. There's a workshop there about how to build, how to make learning, teaching and learning more fun. And I think he used a game. He developing a game. Everything in, he using every game to teach, because he said that no matter how old are you, you always love to play, he said.
Absolutely, absolutely.
That's one I still remember, but what he said.
And it's still very popular in the UK.
Yeah.
It's still hugely popular. I would say, I because of COVID, I've not been to the US for a few years now. I've not been since 2019, but I know gamification is still very, very popular in the USA. It's still a big theme in J.Chem Ed, every single issue. So I typically end up peer reviewing a lot of articles based on gamification. So somehow I think I've worked my way onto their list as one of their go-to people for gamification. So I get sent a new paper every 6 weeks or so about a new game. So it's really exciting time actually for this type of learning.
Yes, of course, this is one of the famous approaches to learning, especially in chemistry. Everyone is trying to make the chemistry fun to learn, because as we all know that chemistry is for most of students hard to understand something.
Absolutely. Yeah, absolutely.
So teachers should have another alternative way to teach chemistry in a fun way. Okay, so let's move to the question and answer session. Actually, there is one question here from Mrs. Rini Maharini. Thank you for your interesting presentation, Mr. Dylan, regarding escape chemistry room. Could you please explain your experience again, more detail about your diagram or spectroscopy activity, particularly clue TLC to NMR? Is this TLC data from a compound or a group of compounds? And how does it connect to an NMR data? Thank you for your response. Okay.
So I think we're talking about this diagram. So this is the sequence that students had to work their way through the activities. So what I'll say first of all is students didn't know this was the order they had to do them in. So when they came into the lab, they were given a briefing and they were given a statement sheet which told them they had to start with the infrared. Okay, so that's all they knew. They didn't know what the other activities were, and they didn't know what the order they had to do them in was. And you have to do them in the right order to get the right code to unlock the box at the end. So if you don't do them in the right order, let's say you do all 4 activities, but you do them backwards. Let's say you do 1, 4, 3, 2 in that order. You will get the digits that correspond to the code to unlock the box. You'll have the right numbers, but you'll have them in the wrong order. So when you turn the barrels of the lock, it won't unlock. Okay. what happened, the way we structured this was they had to present answers to each of the individual challenges to the student facilitators, so to the research students who were running the session, basically. When they presented the right answer to them, they would then tell them that they got the answer right and they needed to move on. To number 2. So, for example, when they're doing the infrared, once they had successfully, for the infrared spectrum, they were given a sample. They didn't have to make the sample. They were given a specific sample. They had to prepare it for analysis on the FTIR. They had to run the infrared, print off the spectrum, and then they had to annotate the spectrum with the key functional groups that were present. Once they had identified, and I can't remember how many, but they had to identify a threshold number of functional groups. They had to identify 3 functional groups or something like that. Once they had done that, they could present that to their facilitators. They then had to do the word search. So they had to find the keywords related to spectroscopy in this word search format. And once they'd done that and presented that to their facilitator, they would be told the next activity for you is TLC. Please move on to that one. Each time they solved part of the problem, they were given a single digit number. So they were given that number when they presented their answers to the facilitator, and the facilitator would give them the number that was relevant to that experiment. So if they did them in the wrong order, they would get the number, but they would be entering it into the lock in the wrong way around. When they did the TLC, because I think, sorry, just bring the question back up, because the TLC data from a compound or a group of compounds. So they were analyzing ink samples for the TLC. So the idea was they had to break down the ink into its constituent dyes, into its constituent colors, and they had to present the order of those colors to their facilitator. So the hands-on activity for the TLC was to actually prepare the dye sample. It might have been a food coloring sample, actually, rather than an ink sample. I can't remember because it's been 3 years. I'm struggling to remember exactly what we did with them there. And then they had to separate that out using TLC. Then they had to present that order. Once they'd successfully done that, they were then told next activity NMR. But they were told that by their facilitators. It wasn't something that naturally revealed itself in the analysis of the spectrum, if that makes sense. Or hopefully that makes that a little bit clearer.
Yeah, I think that's answer all the question. Okay, is there any question? Anyone from the participants? You can raise your hands, or probably you can write the question in the chat. Please, if you have any question, do not hesitate. Oh, yeah, Diva Andika, raise hand, please. Could you please open on your camera, please? So please, the operator.
I'm not in the right place, I guess.
Oh, I see. So you just want
okay.
to turn off your camera. Okay.
Yeah.
Please.
Okay. So Dylan, in the game, there will always something called competition, right? And competition, as I know, is not always a good thing. A student from Indonesia can be a little bit too competitive, I guess. And sometimes, I say sometimes, can be a little bit barbaric. So my question is, if the result of the game we play is good, the grade of the student we teaching is improving, but the social relation between the student are getting worse. Should we play the same game, or should we try another type of game in the future?
Yeah, I think that's a really important aspect of it, actually. And it's one of the things that I have always had some difficulty deciding what the best approach is. Sometimes I think, not all games have to have winners. However, if you want to get it published in Journal of Chemical Education, you usually do need a winner, because the reviewers will just write back to you and say, who won? Which is unfortunate, because you can have a really, really good game without having that same competitive element. I think we've got examples of them that we've used that don't necessarily have a traditional winner. They have a successful outcome, but the outcome isn't measured against the outcome of others. So you wouldn't necessarily say you have a winner. I think it's something that the teacher clearly has to monitor very, very carefully when they're observing the students playing this. And I think we absolutely cannot do anything that damages that social dynamic of students playing against each other and maybe getting a bit too enthusiastic and a bit too carried away. I think engagement and enthusiasm can be good, but I think it can very easily get out of hand when we are playing these types of games. So whether it's a case of finding an alternative game format to use, or whether it's a case of adapting the existing game format, I'm not entirely sure one way or another. The same game might work with slightly adapted rules to maybe tone down that competitive element and maybe make it less significant to a successful outcome. But I do agree, it's something that we do clearly want to avoid, and we absolutely don't want students fighting with each other over the outcome of a learning game. That's the last thing we want, definitely.
Yeah, of course, we don't want a student after after the class over, David.
But you can really easily imagine it happening, unfortunately, because some students do get very carried away with these kinds of things.
Take it seriously.
Absolutely, some students will take it really, really seriously.
Yeah, but I think the most important thing is game could, raise some, improve students' motivation, students' cooperation, collaboration is, I think that's the most important thing, and in a fun way.
And I think if you're developing a new game, I think that's why we pilot them, really. I think pilot it with a small group and measure the outcomes. And, part of that measurement might be something using a formal research tool, might be something using a questionnaire or focus group or what have you. But part of that evaluation might involve the observation of the teachers. And I think that's always an important element for me, because you need to get a feel for how students are interacting. And you could do some of that by self-reported ratings afterwards. You can get students to say, well, how effectively did you work with others? But I think sometimes it is, well, always it's good to have an objective measure of that from the teachers themselves observing it. And I think one of the things that I would always be looking out for is the perhaps social behaviors that we wouldn't necessarily want to encourage.
Yeah.
And if we were to spot that, if we were to observe that kind of behavior, then perhaps we should step in at that very early stage before we run the game out with a full cohort. And maybe we should adapt the game or change the rules or make it a more friendly learning environment rather than a confrontational one.
Yeah, I think it's really it works. Yeah, from the pilot. We will see how this game affect. Yeah, so I think, yeah, Dylan, I totally agree with you. So when we design the new game, we have to pilot it in a small group so we can see what we can predict what will happen in the future. The future, yeah, I think that is the important thing. Yeah, of course we don't want to. We are going to avoid the negative interaction between students. So because we want to make it fun, we want to make it we want to make students enjoy learning the concept. Yeah, we want to create the fun way, the fun situation for students. So yeah, is there any other question from the participants? I think gamification is not only for using a game, right, Dylan? We can
Absolutely.
We can also using like maybe you already mentioned about it before previously, but using Mentimeter, using Kahoot, or using quizzes, or using something. We don't have to, develop the game by ourselves, or we can use other games or technology which is quite fun to use in the classroom. I think.
Yeah,
And we
definitely. And
also, yeah. What do you think about it?
yeah, I think it doesn't have to be a large scale intervention. It could be something quite simple that we do. So imagine we're running our class, and we want to try something new to try to support student engagement, get more students feeding back to our questions or whatever it is that we're doing. And exactly what you've suggested would be a really great way of doing that. And we could use Mentimeter or Participle or whatever technology we want to run polls, to run interactive questions, to run anonymous comment features. And I think these are borrowing elements of game mechanics. I think we are giving students the opportunity to try things out which are inspired by games but are not games themselves. And this is very much within the spirit of gamification. So we don't necessarily have to make a huge change to our teaching practice to embed gamification, because actually developing a new game and testing it out before we run it with our cohort, that can be quite a long process. It can take months of development, testing, retesting, evaluating the data. You could be developing a game for months or even a year or so before it's ready. We don't have to, gamification doesn't necessarily mean something as big as that, though. It could be something much smaller, much more confined. It could be something that we could describe as an easy win or a quick win, I suppose, which could be embedding some polls into our lectures, or using something for the laboratory environment, like doing pre-laboratory activities and getting students used to, I don't want to spoil my next talk too much, but getting students to do simulated versions of the experiments and things like that. These are game-based elements without them actually forming a game. And they can be very effective at getting students to think about the subject differently, giving them different ways of engaging with the topic and engaging with the session.
Yes, of course. Yeah, because one of our lecture here, always using something like Mentimeter or quizzes, or to engage students in learning, because it's quite fun.
Oh yeah, absolutely,
Really
absolutely.
fun. And I remember that you've once used that in your class, in your talk.
That's right. Yeah, that's right.
Yeah, well, in Leicester. So jadi let me talk in bahasa Persia. Jadi gamification ini nggak selalu harus pakai game, atau kita harus mengembangkan game kita sendiri gitu ya. Jadi sebenarnya kita juga bisa menggunakan seperti Kahoot, seperti yang lain gitu ya, seperti Mentimeter, atau kita menggunakan quizzes di dalam kelas. Itu juga sudah termasuk kita menggunakan gamified approach. Jadi pendekatan yang gamification ini gitu. Jadi tidak harus melulu, karena kalau kita mengembangkan seperti yang Dylan katakan tadi, itu takes time gitu, kita butuh waktu yang agak panjang. Tetapi kalau kita mau yang seperti itu ya juga silahkan gitu ya. Tetapi penggunaan game-game yang sederhana atau teknologi yang bisa membantu kita untuk menarik perhatian siswa dalam belajar, itu juga bisa kita gunakan gitu. Nah, saya rasa itu adalah satu poin yang penting ya. Jadi tidak harus selalu yang wah gitu ya. Nah, silakan, mungkin ada pertanyaan lagi dari peserta yang lain. Kalau ada pertanyaan dalam bahasa Indonesia pun tidak apa-apa, mungkin bisa disampaikan. Atau ada yang ingin angkat tangan lagi, please raise your hand if you have some question. Karena ini topiknya sebenarnya menarik. Dylan, this gamification approach is not only using for teaching, right? It also can use as in evaluation.
Yes. Yeah. So it's used in a lot of different contexts, but in a lot of different industries. And I think one of the most interesting kind of research and evaluation application is what I was talking about right at the start, where it's used in marketing quite a lot, actually, to investigate customer attitudes, customer perceptions about products. And it's sometimes used as a way to help support new product development, by getting an insight into what types of things customers might potentially buy into in future. So it's been used as a kind of psychoanalytical tool by some industries, by some sectors already. I've got to admit, I don't know many educational researchers who use gamification as a out-and-out research tool. I'm imagining it probably does happen, but probably at pre-university levels, because I think it could be quite a powerful way to learn about the behavior of kind of elementary school students and the way that they interact with a subject, they engage with a subject. It could be quite a good way of learning about that, but that kind of sits a little bit outside of my area of expertise, so I don't really know very much about it, unfortunately.
Okay, so I have a question. What we should consider if you want to, use this approach, gamification approach, in our lecture, in our class. So what is the main thing that we have to consider first? I
think being very clear in terms of the structure of the activity with the students is the most important thing. I think providing a very robust set of guidelines that the students can follow step by step without having to put their hand up and say, what do I do next? What do I do next all the time? I think that's the most important factor for success. The second most important thing I would recommend is something I said earlier that we learned the hard way when we did Go Fisher. Don't use the game to introduce the topic. Use the game to consolidate the knowledge of the topic after they have learned it in a different type of experience. So maybe students have classes on the topic, and then after they've had those classes, then do the game, rather than do the game first, because otherwise it can be overwhelming. I think the cognitive load of learning how to play the game and learning about a new topic is just too much for a lot of students. I think pragmatically, though, one of my tips is try an existing game before designing one yourself. So there are lots and lots and lots of games in chemistry and science that have been published and are freely available. So if you look on the internet, you'll find lots of examples of chemistry and science games. If you look at Journal of Chemical Education, there are many, many examples of really great games in there. Try one of those with your class so that you get to learn what it's like to run an educational game in your class before you start thinking about designing your own activity. Because I think it gives you some valuable lessons in terms of the format, structure, and environment that you're working in when you're using games. Okay. Yeah, I think, yes, of course, I totally agree with you. I experienced it myself when I tried to develop the card game. It's quite, it spent more time than I thought. Yeah. Okay. There is one statement. No, it's not a statement. Perspective that a game can only use for the specific or the certain age group of students. So why now is increasing? The number of using game in the university is increasing. So actually, what is the best year for students in the university to, using this approach? That's a really difficult question. I'm not 100% convinced there's an answer to it, actually, because I'm one of those people who believes that games can play a role at any stage of education or development, to be perfectly honest. I think I can learn from educational games, even though I've been a practicing academic for 15 years. So I think there are things that I can learn from my professional practice from playing games. So I wouldn't necessarily say games, I wouldn't fall into the trap of saying, oh, games are great in first year, but don't use them at the end of the degree program, because I'm not convinced, to be honest with you, there is an ideal age for doing that. It's a really interesting observation, though, that, this is something that wasn't done in universities until quite recently. It's something that has emerged relatively recently at university level. I think it's part of a broader innovation, to be honest, a broader drive to innovation, because, you know, if you go back 20 years ago, like I was saying in my last session, you wouldn't have found any UK universities doing context and problem-based learning, for example. So I think universities have opened up a lot more to doing innovative teaching in STEM subjects in more recent times. I think another factor is the availability of technologies that facilitate it. So the ability to do things digitally and to design apps and to design online experiences relatively easily, that has encouraged people to try this type of experience out who probably wouldn't have tried before the advent of digital technologies.
Yeah, okay. I think it also depends on how good we design, what experience that we want to students have after playing the game. I think it's.
Oh yes, yeah,
we
absolutely.
have to think about.
Definitely.
Yeah, of course. Okay, it's I think the time is already 5. Is there any question? I think no. Okay, maybe yeah. Okay, if there is no question anymore, like I said, I just want to emphasize about this because it is related to my last question. What is the ideal age? I think there is no ideal age, Dylan, because we can. Yeah, like I said before, no matter how old you are, you always love to play a game, you know.
Exactly.
So,
yeah.
So I think gamification approaches can be used in every stage of the level education. So yeah, if Oke, oh ya, ini silakan kepada para peserta dipersilakan untuk mengisi absen ya, silakan sudah diberikan linknya. Nah, okay, if there is no question, we can. Dylan, thank you so much for the talks today. I really enjoy the talk.
Thank you very much.
Gamification, and I think all the participants as well. So you also provide the examples. Yeah, the game that you use in the University of Leicester in the last 5 years. Yeah, I think it's really nice and it's really good, and probably all the participants could have something or learn something from your talk, from your presentation. Thank you again for your kind to giving a talk in our department. So the third talk will be on the 13th September, if I'm not.
Yes, I mean that sounds right. Yeah.
It's about the laboratory.
Yeah, that's right.
Laboratory, yeah. So keep it. Hopefully, it's already the participant will participate in this. Can wait to see your presentation in the for this third talk. It will be the last talk, yeah?
That's right, yeah.
Okay,
fantastic.
Thank you. So
thank you for inviting me again.
Yeah, we are pleased to have you in here. Okay, do you have something to say, Dylan, before we close it?
No, I just wanted to thank everyone again for coming along, and to thank everyone who's asked some really interesting and thought-provoking questions. So thank you very much, everyone. And I will see you in a few weeks.
Okay, see you in a few weeks. Fadil, saya tutup ya. So, terima kasih atas kehadirannya semuanya. Kita tutup. Kita ketemu lagi insya Allah tanggal 13 September. Ya. Nanti akan diberitahukan, nanti akan diberi link pendaftarannya jika ada yang ingin mendaftar. Mudah-mudahan guest lecture pada sesi kedua ini memberikan makna, ya, memberikan pembelajaran tertentu. Jika ada pertanyaan yang terkait dengan ini, nanti silahkan ditanyakan. Fadil, mau ditutup sama Fadil atau saya? Okay, so I will give it back to Fadil. Please, Fadil.
Okay, thank you to Dr. Dylan Williams, who has delivered the material this afternoon about gamification of learning. It's an interesting material, so we can know better. It's not just about game that we create to improve our quality in learning, but gamification of learning is wider than that. Also teach us to improve the learning system by using something fun like Kahoot and others. But once again, thank you, Dr. Dylan, for this amazing material that you have brought us for us today. But unfortunately, time has passed so quickly that we have reached the end of the event. Thank you to the participants, lecturer, and invited guests who have taken the time to attend guest lecture this afternoon. Hopefully the materials that have been presented can be useful, and hopefully we can meet at another time. So for me, if there are any mistakes in words and actions, both intentional and unintentional, I apologize profusely. We look forward to seeing you again, Dr. Dylan, on our next event. That's all from me. Wassalamualaikum warahmatullahi wabarakatuh, and good afternoon.
Dylan, can we have your presentation?
Oh yeah, of course. Yeah. I'll email both of them to you that I've done so far.
Some of the participants asking about the presentation since last week. Okay, thank you.
Yeah, definitely. I'll email them to you now. Yeah.
It's really nice to talk to you and see you.
Great to see you again, and I'll see you in a few weeks. Have a good trip.
Yeah, I will go on 15 actually, 15 September.
Oh, okay.
Yeah, 15 September, and I will arrive in Portland on 15 September as well. So,
okay.
see you.
A long journey.
Yeah, it's a really long journey. I will contact you later, and maybe we can, discuss something related to our project.
Brilliant.
Okay.
Yeah, that sounds good. Sounds good.
Yeah. Okay, see you. Bye.
See you. Bye.